Hey everyone, I hope you all are safe and doing good. So in the series of learning C++ programming language, we are discussing functions in C++. In previous video, we have seen the basics of function. That was about introduction to function, like what is function, why we need function, then what are built-in function, what are user-defined function, function declaration or prototype, function calling, function definition, as well as 4 types of function. Function without argument and without return type, function without argument with return type, function with argument without return type, and function with argument and with return type. Right, these 4 things, 4 type of function with proper example. Right, advantages of using function and all we have seen in previous video. Now in this video we will see what are parameter passing mechanism in function, how to pass parameters. Right. So there are 2 types of these mechanism, parameter passing mechanism. One is call by value and call by reference 2. So these things we'll discuss in this video with proper example, with proper program. Right. First of all, we will discuss what is an argument and what is a parameter. Difference between these two. These 2 terms are a little bit confusing. Let me show you this thing with example. So see, this kind of example we have seen in previous video. We have a function add. There we are adding 2 number, right? This is function definition. Here we have this is function definition, right? We don't have any prototype of the function because we have defined this function before calling. In main we are calling this function. So here we have int xy, sum is equal to 0, and we are asking from the user the value of xy, and we are calling this function add by passing these x and y to argument, and whatever it will return, it is returning a plus b. See, return a plus b, so it is returning, we are adding to int value, so it will return int, so return type is int, and in some variable some variable we are holding, we are fetching that value, whatever this add function will return, right? And then some I am going to print. Right, now here what are parameter and what are argument? So while calling the function I am passing x and y, so these are known as arguments, right? The values or the variables you pass while calling the function, those are known as arguments or actual parameters, right? And the variables which we declare in function definition, these are known as parameters. So here a and b, these are parameters, and x and y, these are arguments. So the parameters are just placeholder to fetch or to store the value, whatever value you pass in arguments while calling, right? So but these arguments are actual values you pass. So here x y means x and y value, whatever you will enter, user will enter like 3 or 4, those actual values are to be passed 3 4 here, and then a would be stored in a 3 would be stored, and in b 4 would be stored, right? So you know now the difference between parameter and argument, and these arguments are also known as actual parameters, and these parameters are known as formal parameters or formal arguments, and these are arguments or actual parameters or actual arguments. These are a and b are parameters or formal arguments. So now we got the difference between parameter and arguments, right? Now we are passing here the value like maybe x, y, or rather than asking from user, if I write something like this, let's fix this, and I am passing 3 and 4. So the 3 and 4, these are arguments, a and b, these are parameters. So whenever you pass here values or the variables, then this data is to be passed by value or call by value method. 2 type of mechanism are there to pass these parameters, these arguments. One is call by value, second is call by reference, or pass by value or pass by reference, right? Now what is call by value? So first we will see what is call by value, right? So in this case, these 3 and 4 we are passing, this is call by value. Here, what is this in this case, call by value? A copy of these variables, these arguments are to be passed, not the original arguments, not the original data, not the original values. A copy of these are to be passed, right? And in parameter A and B, copy of these variables, these arguments are stored, right? So here if you take x and y, then x and y are different. And a copy of x and y, whatever the value is passed, which is in A and B, right? It's like I have my like my own notes of C++, and if student came to me and asked me, like, please give me notes, ma'am. So what I'll do is, I'll not give my original notes. What I'll say is, you just go to that photostat shop and just copy it, right? So the original notes are with me and the students have a copy of my notes, right? So whatever, like this. So one question for you is, if now the student modify those notes, like maybe highlight something or add something in those notes, any definition or anything, will my notes, my original notes would be affected? Obviously not, because student has a copy of my notes. So in that copy only, that modification would be done. My original notes are with me and those would be unaltered, would be not modified by the student, right? You got it? That is why in call by value, the actual value would not be modified. Only the copy, whatever the value in A and B, that would be modified or changed in call by value, because we are just passing a copy of the variables, right? So like this, if I do this thing, suppose I have a function modify number and like int n. This is suppose only the prototype or the declaration. We can, this n is optional, the name of this is optional. And int main, suppose I have like int a variable a, that is 5, and I'm calling this function modify num and I'm passing this a, right? So let's define this function here, and in this we are just changing this, because 5 we are going to pass in a and I'm just changing the value to 50, right? That's it. And suppose in this we will print this. We are just printing this and we will print this value here before calling and after calling. We are printing value of a. Okay, now this is before and after we are printing this. So what you think, what output you will get? Pause the video and just try this out, dry run this and just let me know in comment section what would be the output. Let's run this and I'll show you the output. See, before calling, a is 5, within modify num value of n is 50, because now we are in this, so within modify num the value of n is 50. After calling, the function value of a is still 5. Value of a is still 5. And if you are confused, like here we have a, here we have n, so let's name this as it is, a and a. In that case also, you will get, see, same result. Before calling, value of a is 5, then within modify function value of here a is 50, and after calling value of a is 5, still 5, means the original value is 5 and that would not be changed, right? So let me show you the working, how this is, what is the internal working of this thing. So let me show you what is happening behind the scene in call by value, right? So here, first of all, control will go to here in main function. So in main memory, obviously in RAM that program would be loaded, right? So in stack, one stack frame or the memory would be allocated for this main function. So now active frame is this main. So now in this main, we are having a variable n which is having value 5, right? So in this stack, in this frame, or the value for the local variable for this main would be allocated, right? So here we have n value is 5. Now we are printing just cout n, so 5 would be printed. Now we are calling modify n. So here we have n, so this 5. Value is to be passed here, right? Now active frame is this modify. we have another stack frame which is pushed into this stack. Now active frame is this modify, right? Now here we have a parameter. This is argument, this is parameter. So here we have again n which is having 5. So this n and n both are different variable, right? This is local to main and this n is local to this modify. Right, now n is 50. So here we have n is 50. Now it will print 50. It will print 50, modify n. Now as soon as we see this closing bracket means control will go back to the calling function or the caller function. Caller function is main. Here we are calling this modify. Now this is popped back from this stack. Now everything is destroyed. This n is now gone, right? Because that was local to this function only. So this memory is now freed. So this n is still 5 because we are here. The copy is to be passed and there we have modified the value in that copy, right? Now modify n, now see out n. Now again value is 5, so 5 would be printed. That is why in call by value the actual value is still same. And this return, so this would be popped back from the stack and that's it, right? I hope you got the basic idea of the behind the scene how this is working, right? So now we got this, what is call by value. But what if you want to change the value, original value? In that case, we cannot pass this number or the argument by call by value. We have to pass this by reference. So for passing, for call by reference also we have two methods. We can use pointers or we can use here in C++ we have a concept of reference variable. That also we can use. The concept of pointer we have discussed in C. If you have gone through my that playlist like call by value and call by reference using pointer, that I'll show you here also. But here one more concept is there that is of reference variable. Yes, in C++ we have a great concept of reference variable. What is reference variable? Let me just tell you in brief. In detail we will see about this reference variable in a separate video. It's like, in simple term if I say, it's like an alternative name to the variable or alias of that variable. Suppose you have a nickname. Suppose I have like Jayanti, Jenny or any nickname. So if someone call Jayanti, then obviously I'll respond. If someone call Jenny, then obviously I will respond, right? So it's like a nickname or alias name or alternative name of that variable, right? So in call by reference, we pass the values we pass the reference of the variable. We don't pass the copy of that value, we pass the reference. Means basically we pass the address of that variable, right? Suppose one example we can take. Suppose I'll give you, or me and my friend are having something in Google Drive. I have sent something in Google Drive and we both have link of that. So, and we have access to modify to that document or to that thing. So if I will modify that document here, then obviously my friend will see that modified document. Or if my friend will modify in that Google Drive that document, then I will also see that modified document, right? Because we both are having address or link of that one file. The file is one only, data is one only, and we are having address of that data. So we can modify that data and both me and my friend will see that modified document, right? And if me and my friend, if suppose I have a document and I send that document using Bluetooth or something else, some other software, I have shared that document on WhatsApp to my friend, right? So we both have copy of that document. If my friend is going to modify that document, then that modification will not be there in my file because I have my original file. Now we both are having copy. So that is like call by value. But if that Google Drive example is like call by reference, right? So we just create a reference variable, right? So how this is going to work, how to create reference variable, we just use that ampersand symbol. It's not like address of here, right? It's ampersand symbol, right? So here we pass a only, but while in this definition of the function, we are having here int this ampersand a, or if you take any other variable, that also you can take, right? Suppose I am taking x here. So here x is equal to 50. Value of x, and here we are printing x. Right? So now this x is now reference variable of this a. Right? So obviously in declaration also you have to modify int and this ampersand symbol, because here we are using reference variable. So this name of the variable also you can take, that is also fine, but that is optional in declaration, right? Now it will modify the actual value. See. Okay, let me just. See, before calling function the value of a is 5, within modify value of x is 50, and after calling the function value of a is 50, it has been modified. Because here now this reference variable, this x and a, both are pointing to the same location. Right? Let's understand this thing. See, if I give you example of a reference variable, like I have int a is equal to 5. And we have a reference variable int, this ampersand symbol, and b is equal to a. Now the both b and a, now this b is alternative name of this a. So what do you think, what it will return? If suppose both a and b are same, like suppose Jayanti and Jenny both are same, so obviously address of Jenny, address of Jayanti both are same. So this, both the statements should print same address. Right? Because this b is alternative name of this a. So b is like reference variable here. Let's run this and see it will work or not. So address of a is this and address of b is this. See, both addresses are same. Let's put handle here for a new line. See now, a and b both are having same address, means both are same variable, just with alias name, right? If you change in this a, now a is equal to 56, and if you print here C out b, so what it will print? 56. See, 56. We are just changing a, but b is printing 56. And before this a 56, if you print b, then first b was 5, then it is 56. So first is 5, then 56. So I hope you got little bit idea of reference variable, right? In detail we will see in different video. It's not exactly pointer. These are similar like pointers, but are having some differences. So we'll see in a separate video difference between pointer and reference variable, right? But for now I hope you got the basic idea, right, of reference variables. So that is why here I'm just creating, and you have to declare, while declaring you have to put this ampersand symbol in declaration. That's it. And the data type int, because this a is of int type. So here data type of this reference variable while creating should be same, because we are passing a, that is of int type, and this x is just a reference variable, right, of this a or alias of a. So just pass a, here create reference variable. So now both are pointing to same memory location. So whatever you will change in this x, that obviously would be changed in the original value, right? So that would be reflected outside of this function also, right? Now one is this, using reference variable in C++. This is the concept in C++, not in C. We can achieve this call by reference, but other than this we can use pointers as well, right? Now if you are using pointers, if you have a basic idea of pointer, then how we can use, because pointer variable contain address of another variable. So we pass here address of the variable, right? So we pass here proper address of operator we'll use, but here we will not call it address of operator. It's just a symbol, ampersand symbol, while you are declaring a reference variable. But here it is address of, because you are passing the address. So if you are passing the address, so here you should have a pointer variable to receive that address, because only a pointer variable can contain address of another variable. So we are having pointer variable int. This is how we declare pointer variable. This, but here now in prototype also you have to change it, because here we are using a pointer variable, so here data type should be int asterisk, right? And that is fine. But here we cannot simply use x, because x is a pointer variable. X is 50 is nothing, right? Here we are passing the address, so we have that address in this pointer variable, and to access whatever the value at that address, we use indirection operator, and that is also asterisk. So asterisk 5 is equal to 50. Now we are using indirection operator to access that value, and we are modifying that value to 50. Now this will also modify the value of a, right? See, before calling value of a is 5, after calling value of a is 50, right? And here see, it is printing address, value of x is, because we are simply printing here x, and x is a pointer variable. Pointer variable are containing address of a, so it is printing address of a, not the value. If you want to print value, then asterisk. Let's run this. Now the value is 50, after modifying value is 50. So this is, we are achieving this call by reference using pointer variable, and in previous case we have done this using reference variable. So 3 things we can do, 3 methods, like basically we have. Methods are do call by value and call by reference, but call by reference we can achieve with 2 things, with pointer variable or with reference variable in C++, right? I hope now you got this thing, the mechanism and all, what is difference between call by value and call by reference. So if you want to modify the original value at some point of time, just use reference variable or pointer variable, right? Or if you don't want to modify the original value, just use call by value. But in call by value is a little bit slow, that process, because proper copy is to be passed, another variable is to be created in that function, local memory, in that memory, right? So for copying also it is going to take some time, so efficiency is less, right? So it is a little bit slow, so better to use call by reference. Then no copy or no copy of the content would be done, right? No copy would be passed, just the address, right? And we are just directly accessing the original data, right? No copy is to be done. So let's see in call by reference here. Suppose here we are passing modify n, and here we have address of, so not address of, it's just ampersand symbol. While creating reference variable, we don't call it address of n, right? So this ampersand symbol and n. So this is a reference variable. Let's take a different name here. Suppose here I am taking a is equal to 50, and here we have n. So it's like, here we have in main function now, at first we have n, which is 5. We are just printing 5, we are calling this modify n, and here it will see we have a reference variable a. So now active frame is modify for this function, this stack frame, right? And here we have a, but which is a reference variable to this n. So it is same as n, right? Both are pointing to this same value 5, just an alternative name to this value 5. One is n, one is a, right? Like Jenny and Jayanti, both are name of me only, right? So now we call a is equal to 50, means here only it will change 50. So see out n, so it will print 50, and here also see out n. Now n is 50, 50 would be printed. After this frame would be erased, means this reference variable is no more now, but still value has been modified. It's like Google Drive example. So we are getting 50, and after return this is also popped back from the stack, and that's it, right? And if you use this using pointers, in that case In this case, in pointer case, we are, first of all, main function would be called, so a stack frame would be pushed to this stack, right? Here we have like n5, so n, a variable that is 5, we'll just print 5. Modify address of n, so suppose address of n is suppose 1000, suppose address of n would be passed, right? So address of n would be passed, so here there should be something to hold that address. Only a pointer variable can hold address of another variable, right? So that is why here I'm creating a variable a, that is pointer variable. So once control will go here, means this modify, one another stack frame would be pushed into that stack for this. Now active frame is modify, right? Now here we have a, but this is a pointer variable, and that is storing address of n. Address of n is 1000, so it is storing 1000. Here we have 1000. Obviously now this is pointing to here only, because address is 1000, so using address we can access the value. If you have address of me, then you can obviously access me. You can send gift, right? But you don't have address. Okay, it's fine. I don't need gifts. Now we want to modify this 5. So if you simply say a is equal to 50, that would be error. You cannot directly modify a pointer variable or address, something like this, right? So you want to fetch whatever the value at this address. So for that we use indirection operator, which is asterisk. So asterisk a is equal to 50. Asterisk a means asterisk 1000. Asterisk 1000 means whatever the value at 1000, value is 5. So 5, this value would be modified to 50. And now it will print, here we have not n, here we have asterisk a, if you want to print this value 50. So indirection operator and a, so 50 would be printed. Again we are printing here n, so n is also 50, 50 would be printed. So now original value has been modified using pointer variable, means this is call by reference using pointer variable, and that was before we have discussed call by reference using reference variable, right? So if we have pointers, like in C we have pointers, but this reference variable concept is in C++. So what is use of this? That thing, yeah, there is some, drawbacks and also some advantages of using reference variable, but that we'll see in a different video, separate video. Everything about reference variable and pointers and the difference between these two. I hope you got the basic idea and the mechanism behind this call by value and call by reference. So that's it for this video. I hope you got this. If you have any doubt, you can just let me know in comment section, right? So in the next video, we'll see some more about functions, some questions, and how to pass arrays to a function, how to pass string, or how to pass a function to a function, these things, right? So now I'll see you in the next video. Till then, bye. Take care.